Hello, everyone. Welcome back to the Streaming Alchemy Show. I'm John Mahoney, and on today's show, we're going to be taking a look at audio mixers and more generally, audio processing in a live production environment. But before we get there, I just want to remind everyone that we will be taking video callers on the show. So if you'd like to join the show, at the top of the description for the show, you should have this link there. If you go to this link, somebody from the studio will connect you and get you on air to ask any questions or share any comments you may have. All right. So what I really want to preface the show with is the importance of sound in video production. I think all of us could watch a show with marginal video but decent sound if the content was interesting enough. The other way around is a little more challenging for most people. If you have pristine video but the sound is terrible, uh, it's very hard to get somebody to stick with you. So having clean, clear audio is critical to producing great video, and it's something we all need to focus on. So let's jump in. I'm going to go through an overview of audio processing using a mixer, but with some general takeaways from this. So first, let's take a look at a physical mixer that I have here with me, something a little different for this show. If you look at the layout of a mixer, what you actually see here are multiple channels, each one of these channels basically being identical to the one next to it, that take input signals and give you the opportunity to process them. There's then a section over here on the right. And again, for most mixers, it has a very similar layout to this that allow you to take the audio that has been processed in this side and then start to route it out to different points on the mixer using the controls on this side. So I'll go into to start looking at each one of these channels and break it up into each of the sections. But sort of as a rough outline, you're seeing at the top controls that allow you to adjust the level of the signal coming in, controls to let you route that incoming signal to different locations in the mixer, equalizing uh, equalizer knobs that allow you to adjust the timbre or tone of a signal, and then the fader control, which is really the last step in the routing process for how signals move through a mixer. So if we go to the presentation now, hopefully this will be pretty clear to everybody. This is the representation of the mixer. It's pretty close to the mixer we just looked at here, but this is the representation of the mixer that we're going to be using for what we'll talk about today. And one of the things you couldn't see from the overhead shot we did is that every mixer has a set of buttons across a set of ports across the back of the mixer that allow you to take the signals that have been routed and route them into other locations in your studio environment. So this could be everything that could be coming into your mixer, as well as everything that you want to route outside of the mixer downstream to be processed. So if we look at one channel, if we just take and look at, say, this first channel here and what's in it, at the very top, you're looking at the input section. So this is where the signals first enter your mixer. So if you see here, we have two different types of inputs that are available. These typically are not meant to be used together. You'd pick one or the other. Uh, the top one here is something called an XLR input, which is almost always balanced. So a balanced input is slightly different than the more generic type of input called an unbalanced input. So if you look at the diagram I have here, uh, an unbalanced signal is basically going to go down a wire and just come out the other end exactly as it was sent in, with one exception. Uh, if you run this wire in an environment that has a lot of electrical noise, so if you're in a live hall or an auditorium or at a concert, there will be lots of other gear, transformers, other types of electrical gear with pretty strong signals. That can cause interference, what's typically called induced interference, where the magnetic field from one device changes the signal on another device. And that comes across as noise. On an unbalanced signal, you have nothing to do to adjust that. You move the wire, you try to separate things, but that's all you really have as alternatives for resolving noise that comes in on an unbalanced signal. A balanced signal does something really clever. What they do is you send the signal out twice. So in one case, you send the normal signal, and then in parallel with that, you flip the signal around. So the waveforms that are going up now go down. And you send those two signals across, and they get combined at the other end. Why this is interesting and makes a huge difference is that when they combine those signals, they flip them both. So now they're not 180 degrees out of phase, they're completely in phase, except for any noise that got induced in those wires, in that wire going down the line. So what you now have is you have perfect signals, but the noise on those two signals you're going to add together is moving in opposite directions. So waveforms that were moving up are moving down. So when you add those two signals together, the noise cancels out, but the signal itself remains intact. So balanced line signals give you the ability to take and run a signal cleanly across more noisy, complex environments where you don't always have the luxury of running your wires in a clean space. So that I think is sort of the first critical thing. That helps you get a clean signal into the mixer. Uh, the other piece, which I'll just jump in, it's not really critical for live production in most cases, but it's something called an insert jack here. And what an insert jack allows you to do is take the signal that you have coming in here and route it out to external devices that you may want to use to process the audio that's coming in. So this can be for a variety of reasons. You could do fancy equalization, different types of compression, other things that you may want to do. But what it does here is when it sends it out, runs through here and returns, this signal now forms a chain. It inserts this effect into the signal chain that's moving from the inputs down to the gain stage. So it gives you the ability to keep this the limits of the mixer, everything that it can do to extend that now. It's basically the equivalent of what you do with plugins and software, except sort of old school physical boxes, physical wires. And that can be useful for different types of situations. But probably the most important thing I'm going to talk about today, and you never really, it's supposed to give the most important things up front, but in this presentation, the most important thing is this one lone little knob here called gain. And on some mixers, you'll see it also called trim. It can be either. What gain or trim does in a mixer is let you adjust the level of the signal coming into the mixer. This is something that a lot of people, when they work, they can use this sometimes to treat it like a volume control, but it isn't. Volume, when we talk about sound, is the level that's coming out of the channel. That's the volume of the signal. This is the level of the signal coming into the channel, and getting this right is really critical. So if you look at this as sort of a map of audio that could be coming in. At a given level, you have the sound and it should be clear. And if I wanted to hear it louder, I could theoretically just turn up the volume for it. The difference here, though, is that in the real world, there's noise that exists in equipment. Some of the noise could be from the microphone itself if it's further away from a speaker. It can be noise we talked about induced in lines that are coming into the mixer. And it's also just noise in the electronics. Electronics have some base level. And that's usually called the noise floor. Now, the problem you have is if the way you want to go about making the sound louder, if it's too soft, like in this example, is when you turn up the volume on the sound, you're also turning up the volume on the noise that's coming in. So while everything is louder, you're not necessarily getting more usable signal out of it. It's just louder, noisier signal. So what you're really looking for is a way to raise the level of the signal without raising the level of the noise floor. And that is really where the gain control comes in. What you're trying to do with gain control is to maximize the signal you have without letting it distort. So you want to raise that level up from coming in here, So you're still going to have to deal with the noise that comes in directly from this gear, but you're not going to have to deal with any additional noise that may be generated in the mixer itself from nearby channels or other things. Uh, so you want to maximize the signal level without distorting, and you end up creating what's called a high signal to noise ratio. And you'll usually see that when you look at electronic equipment as SN ratio or S/N. But there's a catch here. What you don't want to do is you don't want to edge this up too close to the top. Uh, and there's a reason for that. When somebody speaks, uh, when you dial all this in, there's a dynamic to their voice. So when you're testing, their voice may stay at a certain level. But when they're live, when they're talking in front of an audience, that can actually jump up. It can become louder. So you need to keep in mind that there should be some headroom in there. Uh, the other thing when you're looking at processing a signal is that you may do things further down, like equalization, which could raise the level of the signal and bring it into that distortion range up here. So again, creating a signal level that is very clean, very high in proportion to the noise level in the system, but with enough room so if people talk louder, if they have spikes of sound that come in, or if you do things further down the chain, it still keeps the signal clean. So the next section is the aux routing section, which is really called auxiliary routing. And what aux lets you do is take the signal that you just dialed in and send it out other ports on your mixer to be used in other parts of the studio. So if you think about each one of these signals, they actually are it's just one pipe of signal coming down. And if you wanted to process them separately, the back of most mixers or somewhere across the top will give you output ports. And one of the things that these can be used for is something you may want to add different types of outboard audio processing. Very similar to insert, except now it's not injecting a signal in this single channel, but you can mix it in another part of the mixer. So that's one thing. But the other thing is you can use it to create other types of mixes that other people may want to hear for different purposes in a production. And we're going to show you how to use the aux channels to create mix minus, which is a critical part of a lot of modern productions, especially where they do more and more with remote guests joining shows. Okay, so this is something we've talked about in a few places, equalization. Equalization is a tool you have available to adjust the tone or timbre of a sound that's coming in. And it usually works across multiple frequency bands in the sound you're dealing with. So if you think about old stereos, they used to have a tone knob, which is fairly crude. You just twist the knob and it made it sound higher end or boomier, but you didn't really have a lot of control. EQ is the professional version of your tone knob. So in most mixers, they have at least 3 or 4 levels of control. In this case, we have 3. At the bottom end, you have what's called the low frequency ends, and that gives you everything around 80 hertz. And at the top end, you have 12K, the high end, which is the high frequency sounds, and it gives you a tool to adjust that. Now, when we talk about adjustments, and we talk about 80 hertz versus 1200 hertz, it's not just doing that one frequency by itself. EQ has something in it called Q, which is really the width of the signal that you want to impact by turning the gain for that frequency up or down. So what you end up with now is opposed to adjusting that one frequency, which could be sitting here, as you adjust that, frequencies that are within that space of what's called the Q are also going to be adjusted, but in a nice curve. So it's more of a bell curve where you can control how wide I want that frequency adjustment to be. And it gives you now a range of control. So that is something that in this case, the low and the high, that's built in. There is a fixed Q, which is usually somewhere around a 1 octave range, frequencies up and down. But what this equalizer has that's interesting is it has something in the middle called a parametric equalizer. And in a parametric equalizer, you can actually control what that center frequency you want to adjust is. So in this case, this will let me take anything from around 200 hertz all the way up to 8,000 hertz and pick that as the center frequency and make the adjustment around that. So if I were to use this now, I have a lot of tools at my disposal to adjust the sound that's coming out. But keep in mind something. I thought this was a really interesting chart. There are a lot of variables that come into how you would use equalization within a production. The first and probably the most obvious one is that there are frequency tonal differences between males and female voices. And you have to be aware of that. So this chart here, which I pulled from Eric Bernhardson, had this up on his blog post, on a blog post, and I thought it was great to share with everyone. Uh, for male speakers, the most energy, the force of the sound that's coming through a system, typically what you'd see in peaking, is highest around 125, 130 hertz. And it fades off over a fairly long period with a second peak somewhere around 250 hertz. The female voice is going to peak somewhere in the area of 230 to 250, somewhere in there. So when you adjust these types of when you do these types of frequency adjustments, understand that these two voices are going to have a different curve, and so changes that you make over here will impact them differently. The other thing to consider is that even though this may be, these sections here may be the peak in terms of vocal energy that's coming out, all the intelligibility, the things that let you understand sound, come from a lot of the higher end frequencies that go along with it. So things that are the articulation points in different types of letters and phrases that people will use, those things all depend on higher end frequencies. So typically, the frequency bands that will impact voice will be somewhere between 500 hertz and 3000 hertz. And that would be the area, if you want to make adjustments in the midtones here with a parametric EQ, that's probably where you try to dial in to find the right midpoint and make your vocal adjustments there. High frequencies, you can sometimes roll off if the sound sounds too bright. And again, the low frequencies, even though we talked about having oh, actually, I didn't mention it in the input section for the gain, there is a low pass filter that lets you cut off. There's a high pass filter that lets you cut off all the frequencies below 75 hertz. But here, since you have this control at 80 hertz, you can spread that out and take off more of the low frequencies. But again, you don't want to do too much to impact the overall sound of the voice. And like with most things with sound, less is more. Do the minimum amount you need to adjust the sound for clarity without coloring the sound and making it sound artificial. Okay, so we've gone through all of the processing steps that are involved in bringing an audio into a channel on a mixer. So the last step here is really the routing. Now that this sound has come in, where do I want it to go and what levels do I want to send it out at? So let me start at the top. There's a control up here called the pan control, which is really just short for panorama. In a stereo space, they usually talk about left and right. That is the sound panorama, the soundscape that you're painting sounds into in a stereo environment. So pan lets you decide where in this space I want my sound coming out of this channel to be biased toward. So it gives you the sort of, is it all the way to the left? If you turn it that way, you'd only hear, if you were listening on headphones or speakers, sound coming out of the left speaker. All the way to the right, you hear the sound coming out of the right speaker. This allows you to position it anywhere in between. And by doing a pan control instead of two volume knobs, it keeps the overall level of the sound the same. It simply changes its position by creating that dynamic mix of sound between those two parts of the stereo spectrum. So that's something, to keep in mind when you think about what's going on downstream. But coming into this, a channel is typically mono. So there's not a stereo input. It is simply taking a mono sound and placing it in a stereo landscape for how the user will perceive it. So next to that is a mute button. Mute is great when you have to kill the sound on a particular channel for a known period of time. Uh, it's something that can be ideal if you have speakers that may be coming up in sequence and you simply want to mute all the speakers not at a podium, but unmute the one that comes up to talk. It's great for that. But as a tool for managing sound in a discussion environment, it is not ideal. So I would recommend using mute only if you have that sort of pre-programmed sets of speakers and you want to turn off the mics from other speakers so you don't hear chit chat or other stuff going on in the background while somebody's trying to speak. That will save you in a live production. Uh, but understand the use. If you wanted to deal with speakers that are interacting where there's one primary talker, but you could have others that are actually, jumping in and potentially asking questions or doing other things, what I would recommend is you actually use the slider control, the fader here, to turn them down a bit so their sound isn't as prevalent. And if they start to talk, people will get the beginning of what they say at a lower level, but you can quickly adjust to turn them up. That's much better than using mute to do that type of functionality. So the other piece then, since we talked about the slider, is when I adjust the level of the sound that's coming out, that's what we talked about at the beginning about volume. This is the level of the signal that we're now sending out of this channel to the rest of the mixer. So there are multiple places you can send it in the mixer. So if you look at these buttons over here on the side, these really do that routing outside, out of the channel, and into other locations. The left right is typically what sends the signal out to the main feed that's going out of a mixer. The main feed is usually what you're going to send back to an audience that's watching a show. So this is where you'd mix all the channels together and combine them into something that would be the program audio that you'd want to hear, you want your audience to hear. But there could be other cases where you want to create mixes that may not be for the audience. They may be for, people on the stage who need to hear sounds for specific things that can be going on. They could be for people in a control space where they need to just hear certain instruments on set or whatever that, you would be able to then route differently from the main audio mix. And that's what these two buttons are. The 1, 2, and button dash 3 dash 4 are typically what are called submixes. So if you look at what a submix is, I have the ability to send this audio out, as I said, to the main mix. And there's a slider here for the main mix, which controls that. But in a submix, what I can also do is send this signal out to individual mix channels distinct from what's going out to the main mix. So for instance, if I wanted to set up a submix, say with channels 1 and 2, where all of the vocals, all the speakers, all came in on that channel, I could do that and now create a submix where using this one slider here, this one fader, I could control the overall level of all my uh, speakers. So if you had a conference now, you control overall level and use the faders on the individual channels to control their relative levels. A lot of flexibility in doing that. So you have now 4 of these, so you can use them as stereo pairs or as 4 monos. And these all now can come out their own ports on the back of a mixer. So the main would typically come out, as we talked about balance. That's typically what you'd use to feed an amplifier. But you could also take a balanced or unbalanced output, which you may want to use to feed a computer, which could be encoding and streaming your video. So that'd be a great place to do that. You also have the ability to pull out a mono signal of what's coming out the main. So a lot of flexibility on outputs for that. And you also have the ability to take and pull out each of these submixes. So I could use these submixes here to feed the main, to use them as a staging area to mix sounds together and control their level in aggregate, or I could also use them independently to do other things. So, for instance, if I wanted to have different IFB feeds for different people on a news set, you can use these submixes to do exactly that. They can all be set up, and whatever mix you create there has nothing to do with what's going out to the viewers. So, again, very powerful. The capabilities in a mixer add a lot of flexibility to what you do in your production. You don't need a mixer, but it gives you a lot of flexibility in how you can manage things during a live production and how you have your studio set up. So, I wanted to touch on a mix case before we end the show uh, that talks about something I hear people ask about all the time, and that's mix minus. In a lot of today's productions, what you have are remote guests that will be joining shows, uh, usually over something like WebRTC, live to air, or through Skype or other types of sort of remote audio, video services that are available. Each of those guests needs to hear what's going on, but what they don't want to hear is their own voice coming back at them a couple of seconds delayed, half a second delayed. It can be very distracting and make it difficult for them to focus. So a mix minus allows you to set up the right feed for each one of your remote guests uh, without having them hear themselves. So let's look a bit at how that is done. So right now, I'm looking at 4 channels. This would be the channels 1 to 4 coming in with these 4 guests that are all joining a show to have a roundtable discussion. So right now, I'm going to be using the auxes to create these mix minus feeds for them. With all the auxes shut off, I have no audio going out any of them. So there's no guest audio. But let me dial in each channel one at a time to show you how we'd set this up. So for channel 1, what I would like to do now is I want to send their audio out aux 2, 3, and 4. And I do not want to send any of it out aux 1 because this will be, aux 1 is the channel that we're going to route back to this remote guest. So they don't want to hear themselves. So in doing this now, you see that the other 3 aux channels now will be outputting her audio, but aux 1 is clean and has no sound coming out it. The same now in aux 2 for the second guest. We send their audio out 1, 3, and 4, but aux 2 is shut off. So same result. Their audio would not be coming back to them. And if we look for the other guest, again, the same way. Channel 3 has no audio, aux 3 has no audio going out, and in channel 4, aux 4 has no audio going out. So what we've done in each of these feeds is created a mix minus their own audio, which is where the mix minus term comes from. So each guest now will hear the other 3 guests, and they'll be able to, Brad, hello, I just see you joined. Thank you. I appreciate you signing in there. It's always good to see you. So these other guests now are, again, going to hear everybody else but themselves. And this is really key to dealing with external callers and with remote guests participating this way. Uh, very simple to do in a mixer, but you can apply this to any sort of environment that allows you to mix sound. So I know vMix and TriCaster both provide a lot of the capabilities we looked at sort of physically and on this presentation, but it's all just software based. The theories apply, but I think the key piece in all of this is you want to make sure that the audio coming in is clean. So it really comes back to what we started with, using your gain and trim controls to get the cleanest audio without overloading. And then everything else you do is going to have quality audio that you can work with and manipulate. So that's really everything I wanted to cover in today's show. I appreciate everybody taking the time to join. Uh, there's a lot to cover in the audio space, and this really I wanted to set up sort of a level set for us. But I think audio is a topic we'll revisit multiple times in the future. And one of the things I definitely do want to cover, because I get a lot of questions about this as well, is Dante Audio. So expect that we'll be doing a show specifically focused on Dante Audio, digital audio for production environment in one of our understanding shows. So, yep, thanks to TextBuzz. Thank you for joining. Yeah, getting mix minus right is critical for a lot of applications that people are doing. And it isn't always with guests. I mean, sometimes you may have this on a physical set where you could have different speakers on a large auditorium stage, which couldn't necessarily hear each other. So you may want to create mix minuses that are all local, going back to an IFB for them. So thank you for adding that. I definitely agree. So anyway, for our next show, uh, we're going to talk about something interesting: production uses for PowerPoint. Now, I know we've all been put to sleep by a lot of PowerPoints that we've seen in our lives. Uh, and I've used PowerPoint, so hopefully this isn't one of them. But uh, I think that the key to looking at PowerPoint is it's just a tool. There's a lot of the uses you can have for it that are incredibly creative and can really integrate well in in a production environment and give you tools that you can use to enhance the visual quality of your productions. So thank you all for joining, and until next week, have a good one. Take care.